Okay, so this is a quick video to help with gas stoich in case you still need help with it. It's important to be able to recognize what steps are going on, so I'll talk about those briefly and then do some examples from the homework and the notes and all that. So when you're doing gas stoich, a couple of things you need to be mindful of when you're doing it is you need to recognize what you're going to do. So if I give you some kind of grams of a compound, that means you have to do molar mass at some point. Most likely you're going to have to do some mole to mole converting with the mole to mole ratio. If you see a gas at STP, that means you can use the 22.4 liters of a gas equals 1 mole of a gas, only for gases. If it's not at STP, you should probably use the ideal gas law. That's PV equals nRT. Given the following reaction, how many liters of gaseous oxygen are needed to produce 4.50 liters of gaseous nitrogen dioxide if both gases are measured STP? So with stoich, you need to remember that you need to balance an equation or create an equation if you need to based on the names. So let's see, NO plus O2 produces NO2. Let's put a 2 over here. This becomes 2 N's, so 4 O's on my right. I only have 2 O's on my left, so I'm going to add a 1 here. Now I am balanced on both sides. So because my gases are both at STP, I can just use a 22.4 liters. Start off with what I know, 4.50 liters of NO2. Let's see. So they're both at STP. I'm going to use this fraction right here. So in 22.4 liters, it's 1 mole. So 22.4 liters of NO2 on the bottom, 1 mole of NO2 on the top. Next step. Let's see. I'm at moles of NO2. Right now, I'll tell you that this is 4 steps to get to liters of O2. So this one needs to be the next step after, the third step needs to be my mole to mole ratio. So 2 moles of NO2, 1 mole of O2 on top, 22.4 liters here, 1 mole of O2 on the bottom. So do my math. You can kind of tell that the 22.4 liters will cancel out, but just to be thorough, just in case it doesn't always work out that way. 4.5 times 22.4, let's see, 100.8 divided by then 22.4 times 2, 44.8. I end up with 2.25, and then my sig fig's 3, so my answer is going to be 2.25 liters of O2. What volume of gas is evolved from a reaction between 0.52 grams of sodium and water? The gas is collected at 25 degrees Celsius and 745 millimeters of mercury. So I'm starting off with something, and I'm going to end up with volumes of hydrogen gas. The gas is at, so it means that this hydrogen gas is collected at here. This is not STP, so I need to do the ideal gas law. However, remember with the ideal gas law, you need the following things. You need the pressure, volume, number of moles, R is your gas constant, and T is temperature. If you can kind of tell, you only have a volume of hydrogen gas you're trying to find. This is what you're trying to solve for in the end. However, you need the moles of your gas in order to use this equation. Since we don't have that yet, we have to convert 0.52 grams of sodium to moles of hydrogen gas. Okay, let's try this. going to put a 2 up here for now. Put a 2 here. I have 2 O's on my right, so I'm going to put a 2 over here. Now I have 4 H's on my left, and then now I have 4 H's on my left, so I'm balanced. So I'm going to start off with 0.52 grams of sodium. Oh, I shouldn't do all that yet. Let's see. So I know that it's going to be grams of sodium, so that means I have to use my molar mass on the bottom here. 22.99 grams of sodium, 1 mole of sodium. Let's see, 2 moles of sodium on the bottom, 1 mole of H2 on the top. So now I'm in moles of H2. I can stop with the stoich. With that answer I'm going to plug that directly into the ideal gas law to figure out my volume of H2 because I'm already in the moles of that with my stoich. Let's see. This is 45.98 on the bottom, 0.52 on the top. This is going to give me my moles of H2 for this problem. So the moles of H2, or my N, is going to be 0.0113 ... moles of H2. This was my answer for the stoich. Now, I'm trying to find the volume. My temperature is 25 degrees Celsius, so it needs to be in Kelvin, so 298 Kelvin. Sorry, I put 90, sorry, my bad. 290, yep, that's right. I read that wrong. And then now my pressure is going to be 745 millimeters mercury, but that needs to be in ATM, so I'm going to divide by 760. Approximately 0.980 ATM. So I'm going to keep these long numbers in the calculator because it'll make the answer more accurate later on. So my volume equals 0.0113 ... My R 0.0821, my temperature 298 divided by my pressure, the 0.980 ... So do that really quick. So my moles times 0.0821 times 298, that equals 0.27669 something. Divide that by my pressure. I end up with 0.282 ... So my answer will be 0.28 liters of H2. Box that in. What mass of calcium sulfite must have been initially present to produce 14.5 liters of sulfur dioxide gas at a temperature of 12.5 degrees Celsius and a pressure of 1.10 atmospheres? Here it's the only reason why I'm putting this is that this is actually just a flipped version of the previous problem. I won't solve this, but I will tell you for this one you should be able to recognize that what mass, so eventually I'm going to have to do some stoich. So I need a mass of this solid, so I'm going to have to use a molar mass somewhere. However, I give you enough information right here. So to produce 14.5 liters of sulfur dioxide gas at a temperature and a pressure. So this gives me a volume, a temperature, and then my pressure. So I'm going to use my ideal gas law to solve for moles of SO2. And with these moles of SO2, I'm going to convert that to the mass of CaSO3. So whatever answer N is, whatever number, I'm going to convert this to grams of CaSO3. So 1 mole CaSO3. Looks like this is all just 111, so 1 mole SO2 on the bottom, 1 mole CaSO3 here. Remember, your molar mass comes from the periodic table. If 13.8 liters of C2H4 at 21 degrees Celsius at 1.3 atmospheres burns completely, calculate the volume of CO2 produced, assuming the CO2 is measured at a different temperature and a different pressure. So here, you'll notice that none of these are at STP, so we cannot use 22.4 liters. So what you need to do is recognize that you have a volume of C2H4, a temperature, and a pressure. And these are all for C2H4. Over here, on the other side, we can put that we're trying to find the volume of CO2, and we have a temperature and a pressure that are different from those. So this tells you that because I have a volume here, and a pressure and a temperature, about 317 Kelvin, my pressure is 0.989 atmospheres. So you'll notice that I'm going to use this again, like the previous problem, to solve for the moles of C2H4. That's what I want to solve for. Then what I'm going to do with this moles, I'm going to do some stoich to figure out the moles of this other thing I want to solve for. I want to solve for CO2. So my moles of CO2 is on the top, moles of C2H4 is on the bottom, and that's going to be my mole to mole ratio. Let's see, just so I can get the numbers down at least. Let's see, 2, I think that's it. So 2 C's, 4 H's, 2 O's, 4 O's. So I think that should be good. So let's see, I got 2 moles of CO2 on the top, 1 mole of C2H4 on the bottom, and so this answer that I get, whatever moles of CO2, whatever I get from doing this calculation, that's going to be my moles of CO2, and this comes from the stoich, like it comes from the stoich. This comes from the stoich that we just did, and we're going to use that to determine the volume of CO2. So this means we're doing ideal gas law twice. Alright, so if you have any questions, please let me know. Thanks.